Innovation for the future.
Perhaps you have already chosen or been compelled to replace plastic soda straws with paper versions.
The traditional single-use straws are particularly bad in the marine environment because of the harm they do to sea animals. In addition, they are rarely recycled because they are small, which makes collection difficult. They are also non-degradable. Bans on plastic straws are now fairly widespread, and thus, enter the paper straw.
Our oceans are currently swimming with plastics. It is estimated that there are now 150 million metric tons of plastic in the ocean. More than 15 million metric tons of plastic enter the ocean each year. Americans use millions of plastic straws each day. There is a lot of research now underway on the health effects of ocean plastics, but we already know that some plastics, and the chemicals that attach themselves to plastics in the water, can cause cancer, genetic disruptions, and other ill effects.
But, conventional paper straws are inconvenient to use. Upon prolonged contact with a liquid, they become soggy. Also, when these straws are used to drink carbonated beverages, many bubbles may form owing to their surface properties. What you may not have been told is that the paper straws available today are not made solely of paper.
If made with 100% paper, the straws quickly become saturated when in contact with liquids and cannot function as straws. Because of this, their surface must be coated, with the most commonly used coating being polyethylene or acrylic resin, the same materials used for manufacturing plastic bags and stickers. Paper cups are also coated with these materials. Numerous studies have found that polyethylene coating on discarded paper cups can disintegrate into small particles without being fully decomposed and become microplastics. Moreover, these paper products are made with paper and plastics, two very different materials, and thus it is difficult to recycle them.
Certainly, it is better than a fully plastic straw, but research has shown that the polyethylene coating can break down into small particles without being fully decomposed, adding to the group of microplastics. Additionally, the coating hinders the recycling of paper because it is covered with a very different material.
Currently, there are alternatives to paper straws available in the market, such as polylactic acid, PLA, straws and rice straws. However, it is important to note that PLA straws, also referred to as corn plastic straws, do not decompose effectively in marine environments. Meanwhile, rice straws decompose well in non-marine environments, but they are harder to manufacture and are more expensive.
But there are good news. Dr. Oh Dong-Ip and Dr. Kwok Ho-jung of Korea Institute of Chemical Technology, CRICT, and Professor Park Jae-young of Sogang University have just developed eco-friendly paper straws that are 100% biodegradable, outperform traditional paper straws, and can be easily mass-produced.
This technology is based on a new coating composition made from a well-known biodegradable plastic called PBS, polybutylene succinate, with the addition of a small amount of cellulose, plant fiber, nanocrystals, which is the main component of paper.
The cellulose nanocrystals ensure excellent adhesion of the biodegradable plastic to the paper used in the straw, resulting in a functional straw that does not get soggy and can degrade in the environment or be recycled as regular paper.
The research team made an interesting discovery regarding these environmentally friendly paper straws. They found that these straws maintain their physical integrity when used in both hot and cold beverages. Additionally, the straws did not become soggy when used to stir various liquids such as water, tea, carbonated beverages, milk, and even liquids containing lipids. The team compared the sogginess of the new paper straws with traditional paper straws during their preparation and usage.
The researchers note, conventional paper straws do not incorporate a material that will strongly attach the plastic coating to the surface of the straws. The surface of the straws thus is not uniformly coated with plastic, impeding their use. The most significant limitations this creates are that the straws become soggy when a liquid touches the uncoated part and bubbles extensively form when paper straws are left in carbonated beverages. This is because the uncoated part easily combines with water, whereas the coated plastic part has the property of repelling water, causing the carbonated drink to contact the uneven surface of the paper straws.
During comparative testing, it was observed that a conventional paper straw experienced significant bending when subjected to a weight of around 25 grams after being soaked in cold water for 1 minute. In contrast, the new paper straw showed much better performance even when the weight was increased to over 50 grams under the same conditions.
The researchers highlight the significant advantage of the new straw in terms of marine biodegradability, a crucial characteristic often overlooked in products labeled as biodegradable. Unlike many items that claim to be biodegradable but take an excessively long time to break down, the new straw's composition, consisting of paper and biodegradable plastic for the coating material, is designed to decompose and fully degrade in marine environments. This ensures that the straw will not contribute to long-lasting pollution in the ocean.
In general, paper or plastic decomposes much more slowly in the ocean than in soil because of the ocean's low temperature and high salinity, which impede the growth of microbes, explains a press statement from CRICT. The research team performed a decomposition test in a marine environment by immersing the straw samples at a depth of 1.5 to 2 m on the coast near Pohang, South Korea.
As shown in the image, regular plastic straws and corn plastic PLA straws did not decompose after 120 days. Conventional paper straws preserved their shape and lost only 5% of their total weight. Meanwhile, the new straws lost more than 50% of their weight after 60 days and decomposed completely after 120 days.
This technology is but a small step toward the direction we need to take in this era of plastic, says lead researcher, Dr. Oh Dong-yeep. Turning a plastic straw we often use into a paper straw will not immediately impact our environment, but the difference will be profound over time. If we gradually change from using convenient disposable plastic products to various eco-friendly products, our future environment will be much safer.
Thanks for watching. Leave comments below and subscribe to receive more.